Hi guys, my name is Clement. I welcome you to my YouTube channel, GCSE Made Easy Chemistry, which is my specialization of teaching. So I want us to look into the mole concept. You're dealing with this question, which was written in 2017 by the IGCSE students. So the question says, magnesium carbonate reacts with hydrochloric acid to produce magnesium chloride as the equation, as we are given the equation. So from the information that we are given from the question, we are told that the volume of the hydrochloric acid which was used was 50 centimeter cubed. This is the volume of the acid, and the concentration of that acid was 2.0 mole per decimeter. And now you have to look that, because you are given you are given quantities with different units, you have to make sure that your units are the same. One thing that you have to always remember when you are dealing with volumes and concentrations is that our standard unit which is used, it is decimeter cubed. Decimeter cubed is our standard unit. So whatever that you are given can either be liters, milliliters, or centimeter cubed. Make sure that you convert them to decimeter cubed. So according to the question, you are given centimeter cubes. So you will have to convert the centimeter cubes to decimeter cubes. And our conversion unit is 1 centimeter cubed is equals to 0.001 decimeter cubed. And we are given our volume as 50. Now you have to convert it to decimeter cubed. I'll say x. 50 centimeter cubed is equals to x decimeter cubed. We just do a simple mathematics, which is cross multiplication, and you'll end up with 0.5 decimeter cubed as your answer, which means that the volume which was used is 0.5 decimeter cubed of hydrochloric acid, which has a concentration of 2.0 decimeter cubed. Now our first question says, calculate the number of moles present in the volume of 0.5 decimeter cubed of 2.0 mole decimeter cubed of hydrochloric acid. You have to find the moles of HCl in 0.5 decimeter cubed of 2.0 mole per decimeter cubed. Find the moles. And then our formula that we know is that moles is equals to concentration times volume. And our concentration, we know that it is 2.0 mole per decimeter cubed times 0.5 decimeter cubed, which is our volume. And our answer will be 1 mole of HCl. So this tells us that from the information that you are given, the volume of 50 centimeter cubed with a concentration of 0.2 mole per decimeter cubed, only 1 mole of HCl reacted. That's the answer to our first question. And then the second question reads, calculate the number of moles of magnesium carbonate that reacted with this 1 mole of HCl. From our equation, we have magnesium carbonate reacting with HCl. And according to the equation, when it is balanced, we are told that 2 moles of HCl react with 1 mole of magnesium carbonate. That is according to the reaction, the chemical equation. So here the step that we are going to use the Molar ratio. You have the moles that were present in the 50 centimeter cubed of HCl. Now we want to find the moles which will react with those moles which were present in the 50 centimeter cubed of HCl. So what is going to happen is that we are going to use the mole ratio. We have 1 mole of magnesium carbonate which reacted with 2 moles of hydrochloric acid. This is according to the equation. But well, in actual fact, what happened is that only 1 mole of HCl reacted. Now we want to find with how many moles of magnesium carbonate. You're going to use the simple mathematics of cross multiplication, and this will give you 0.5 mole of magnesium carbonate. This is the moles that reacted with 50 centimeter cubed of hydrochloric acid. And now the last question says calculate the mass of magnesium carbonate that reacted with 50 centimeter cubed of HCl. When you calculate the mass, you know that mass is equals to mole times the molar mass of that compound. The mole times the molar mass of that compound. So now what we have the mole, which is this 0.5, we have to calculate the molar mass of magnesium carbonate. When you calculate the molar mass of a compound, you are going to use what to call the relative atomic mass. The relative atomic mass. And where do we get this relative atomic mass? We get it from the periodic table. You should have a periodic table. And from the periodic table, for magnesium, we know that the relative atomic mass for magnesium, it is 24. That is the relative atomic mass for magnesium is 24. And the relative atomic mass for carbon is 12. And the relative atomic mass for oxygen is 16. So now what will happen is, when you calculate the relative atomic mass or the molecular mass for magnesium carbonate, you are going to add the relative atomic mass of all these atoms which are present in that molecule. It's going to be 12, which is for carbon, plus 24, which is for magnesium, plus 16 times 3, which is for oxygen. We are multiplying it with 3 because according to the molecular formula for magnesium carbonate, we have 3 oxygens. So which will give us 84 grams per mole. 84 grams per mole. This is our molar mass. Now we can substitute it in our equation, which we have the mole is 0.5. The mole is 0.5 times our molar mass, which is 84, which will give us the mass of magnesium carbonate as 42 grams. So this is the end of our question. So in simple terms, the question was simply asking us to find the moles of the acid which was used in the reaction to produce magnesium chloride. And after finding the moles of that acid, now we have to find the mass of the magnesium carbonate which was used. Thank you. I believe this video was so helpful to you. And remember to subscribe to the channel to keep on learning how to solve chemistry questions.